Students, this is the help video for the take-home practice quiz. First problem says the length of a shadow building is 27 meters. The distance from the top of the building to the shadow is 34 meters. That's this. Find the height of the building. That's this right here. So we are doing, that's a leg, and here is our hypo. We are doing leg squared plus leg squared equals hypo squared. Circle, plug, chug. That's going to be x squared, 27 squared equals 34 squared. Yes, at this point you may use the calculator that is provided for you on Alex. So it's not going to look the same as this calculator, but you'll get the same answers. So the first one is 27 squared. That's 729. And then 34 squared. It's 1,156. Equals x squared. We subtract. So I have x squared and minus 729 equals, and I get 427, and then we're going to square root because we're going to undo the square. So here's our square root. And we get 20.66, approximately 20.66. Now, because it says round to the nearest tenth, we are going to do 20.7. Here, it says determine whether a triangle is the side lengths. So this is the converse of the Pythagorean theorem. If Pythag, then a right triangle. So you test each and every one of these. For example, 18 squared plus 32 squared, and then here we have 40 squared. I'm just going to do the first one with you. And you're going to check to see if it works in the Pythagorean theorem. So we're going to go 18 squared plus 32 squared. And we get 1,348. 1,348. And then 40 squared, that's going to be 40 times 40. That's 1,600. They are not equal. Therefore, it is not a right triangle. Let's try this one. 8 squared plus 15 squared and 17 squared. So we have here 8 squared plus 15 squared. I get 289. And then 17 squared, let's check that. 17 squared, 289. That works. So this one is, yes, it's a right triangle. The triangular pyramid is formed, has 3 right triangles. Use the information to find the length of RT. So we want to find this length. Problem is, we need 2 sides, but right now all we have is the 16. So we kind of look at what else we have and see this right here. We're going to find that yellow in order to find the green, because we have right triangles here. So we're going to work with this right triangle first. So I'm going to rotate it so you can see it. That's 16. There is our unknown. Let's call that y. And then this is 65. So I'm going to have y squared plus 16 squared equals 65 squared. 16 squared, 256. And it says, round your answers to the nearest whole number if applicable. And 65 squared, 4225. Y squared. I'm going to minus 256 both sides. And then I'm going to square root. And we get 63. So this right here is 63. Now I can work this triangle to get me my green x, which is what we wanted to begin with, which is RT. So x squared plus 63 squared equals 105 squared. And then you take it from there. So it takes 2 Pythagorean theorems to solve. This one, in the figure below, we want to find the length L to N. L to N. Always keep in mind what you're trying to find. We're trying to find this. Now, obviously, that's a right triangle. So I'm going to call that X. Problem is, we only have one side, 37. We always need 2 sides. So look what else you have here. We have a smaller blue triangle, 5 and 13, that if we solve for Kn, that will give us what we need, another side to solve for x. So I'm going to call this y. So y squared plus 5 squared equals 13 squared. That's 25. That's 169. Y squared plus 25. You minus 25 both sides. We get 144 square root. And then that gives us 12. 12. And that gives us 12. And here we have 2 sides, need a third side, Pythag. So now you can do 12 squared plus x squared equals 37 squared, and you can take it from there. So these require Pythagorean theorem twice. These are your special right triangles. We have 45, 45, 90, 30, 60, 90. Write your responses in radical form. Ready? 45, 45, 90, leg, 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 root 2. So in this example, if this leg is 6, this is also 6. And this hypo is 6 root 2. In 30, 60, 90, it goes like this. 30, 60, 90. Short leg root 3, short leg times 2. And it reads like this. Something times root 3 is 3. Something times root 3 is 3. So our something here has to be root 3. And then times by 2, this will be 2 root 3. Okay, the first one here is a 30, 60, 90. So 30, 60, 90. Short leg root 3, short leg times 2. This one's a little tricky. It reads like this in the margin. Something times root 3 is 2. Something times root 3 is 2. So step 1, you know you need a root 3. But root 3 times root 3 gives you 3. We're nowhere near 2. We know we need a 2 there somewhere. So I'm going to put a 2 here and see what happens. 2 times root 3, that gives us 6. But we need to get down to 2. So I'm going to divide by another 3 because 6 divided by 3 is 2. So the complete answer here is going to be 2 root 3 over 3. When I times that by 2, only the outies talk to each other. That's 4 root 3 over 3. 45, 45, 90, leg, 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 root 2. So this reads, if that's 8, that's 8. 8 times root 2 is 8 root 2. One more example of each. 45, 45, 90, leg, 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 root 2. So this one, the legs are equal. So if that's 2, that's 2. Times root 2, that's 2 root 2. This one, 30, 60, 90, short leg, root 3, short leg, times 2. So this reads, this is a little tricky, something times root 3 is 7. I know I need another root 3 there because that gives me 3. If I divide by 3, that'll give me a 1. You ask yourself, what times 1 is 7? 7. So the complete answer here is 7 root 3 over 3. Times 2, only the outies talk to each other, so this is 14 root 3 over 3.